Welcome everyone to 7.5, Strategy for Integration. Now in this section, we want to take all of the techniques that we've learned over Chapter 7, and we want to put them together in some systematic manner. So that way, when we come across a new problem, for instance on an exam, and it says, hey, integrate this thing, well, we have to be like, well, what do I use, right? We have all of these techniques now. So in this video, we're going to talk a little bit about a way to make a strategy for this thing, and then I have a few more examples for you. So let's get to it. Okay, so I have this remark, which is the four-step strategy for integration. The first step is going to be to try to simplify the integrand. And remember, the integrand is kind of this piece that's inside of the integral. So simplify the integrand if possible. And there's a couple different ways that this could happen, right? We could use algebraic manipulation, trigonometric identities, hopefully to make this a little bit easier. Okay, the second step is to look for an obvious substitution. So U substitution is kind of one of the easiest techniques. So if you can use U substitution, do it. Okay. The third step is to be, well, if either of these work, you should classify the integrand according to its form. So again, if steps 1 and 2 have not led to a solution, well, we can talk about the different types of forms that we've gone over here in Chapter 7. Maybe the first one should be something like trigonometric functions. Those ones are pretty easy to identify. Likewise, the next one should be maybe rational functions. It's pretty easy to identify a rational function. It's just a polynomial divided by another polynomial. And let's remind ourselves, right, if we wanted to study these things, 7.2 is where you'd find trigonometric functions. 7.4, partial fractions, is where you'd find how to integrate rational functions. The third one is maybe integration by parts. This is a little bit more difficult to determine, when should we use integration by parts. Just as a reminder, that came from 7.1. And I guess we'll go over some functions that you can use integration by parts on, look like x to the n times cosine, or x to the n times sine. So n can be any power, x, x squared, x cubed. We also have things like x to the n times e to the x. And we've seen ones that wrap around on themselves, like e to the x, sine x, things like this. But this is not a complete list by any means. All right, and then the third one would be radicals. Sorry, not third, fourth. Radicals. And these ones we solved a lot with 7.3. That was our trigonometric substitution. And then unfortunately, step 4 is try again. If these first 3 steps have not produced the answer, well, the claim is if we gave you the problem, you can do it. You just have to try something different. Okay, so let's go ahead and try to tackle an example here. Staring at this thing, we should say, this is a rational function. So, you can go through, I guess, trying to simplify it, looking for a substitution, but you should recognize this is a rational function right off the bat. So you can kind of skip to step 3. And remember, well, the degree of the numerator is the same as the degree of the denominator, so we need to use long division. Or if you'd like to, you could consider this simplifying it. Either way. All right, so let's use long division. And you have to ask yourselves, what do I multiply by 3x to get 5x? Well, the answer is 5/3. So let's go ahead and multiply through. So 5/3 times 3x is going to be 5x. And 5/3 times 2 is going to be 10/3. Now let's go ahead and subtract, remembering that 1 is the same thing as 3/3, so we get -7/3. That means that we can rewrite 5x plus 1 over 3x plus 2 as the answer, 5/3, plus the remainder divided by the denominator here, this 3x plus 2. And now both of these things we can integrate. I can certainly integrate 5/3, and I can integrate this thing. It's going to be something like a natural log. Okay, so now instead of integrating this 5x plus 1 over 3x plus 2, let's write down the integral of 5/3 minus 7/3 over 3x plus 2 dx. Okay, when I integrate 5/3, this is going to give me 5/3 x. This minus 7/3 is a constant. And then I'm going to have the natural log of 3x plus 2, the absolute value. And then by the chain rule, I also need a 1/3, right? Because if I was to multiply by the derivative of 3x plus 2, that'd be 3. So I need something to cancel with that 3. Okay. And now I need to evaluate from 0 to 1. All right, so if I was to plug in 1 into my 5/3 x, I'd get 5/3. If I was to plug in 0, I'd get 0. Now let's see, the minus 7/3, if I was to plug in 1 here, sorry, minus 7/9, I would get natural log of the absolute value of 5. Well, that's just 5. And then minus a negative, it would be plus 7/9. And now if I plugged in 0, I'd get the natural log of the absolute value of 2, which is just the same thing as the natural log of 2. Okay, and now if you'd like to, you can spend a little bit of time simplifying this down, but that's the final answer. All right, and that's probably a good place to end and take a break, stretch our legs. Now, admittedly, this was an easier example than we're going to see in the second video. So take a quick break, come right back, and we're going to do 2 more examples that are more difficult, but they're things that we can do now that we have all of these techniques of integration. I'll see you shortly.